Okay, this is doing pretty well. Let's make sure we all understand. Okay. So we got several calculations to do with fractions. It's important to be able to do fractions because later on you're going to have to do them with symbols. So we're going to write these out in the way they need to be written out to work if you're doing symbols. Okay, so 5/8 plus 3/4. Well, five eighths plus 3/4 equals what? We have different denominators. You've got to have the same denominator. Okay, but you know, a fourth is just 2/8, right? Divide something up into 8 parts, 2 of them make a fourth. Hopefully that makes sense. You've got 3/4. If you multiply 3/4 by 2/2, you're going to get an 8 down here, and you're not going to change the value of this fraction because 2/2 is just 1. And multiplying by 1 doesn't change the value of anything. That's 5/8 plus 6/8. And now you got eighths. Okay? You got 5 of them, you got 6 of them. That makes 11 of them. Okay? That's 11/8. That's a sufficient answer. But of course, you can express that as 1 3/8, which is going to be convenient if you want to graph it on a number line. Okay, just to demonstrate that, we've got a number line. Here's 0, here's 1. And both of these numbers are less than 1, right? But they're both bigger than a half, aren't they? So when you add them up, you're going to get something less than 2, but greater than 1. Because both of them greater than a half, it's going to be greater than 1. Both of them less than 1, it's got to be less than 2. Okay, so how are you going to do 3/4? And divide this interval up into 4 pieces. Okay, just find the midpoint, divide it in half. Find the midpoint here, and then divide that in half. Find the midpoint of this interval and divide it in half, right? And each of those is a fourth. What you got here is 3/4. They've also got 5/8. Well, you've got this interval divided into fourths. I can divide each of those into 2 smaller intervals. And now there are 8 of them, so each of these is an 8, right? And there are 5 of them. So go 1, 2, 3, 4, 5, and here's 5/8. Okay. Now I can depict the addition. You've got an arrow this long that represents 3/4. You've got an arrow this long, it represents 5/8. Let's give that second arrow a different color. So now we can add this arrow to this arrow. And we get the sum, which is this. So this is going to represent 3/4 plus 5/8. Now, that is 11/8. Or 1 3/8. If I want to locate that on the number line, I can divide this interval into 8, right? Divide it in half. I'll divide each of those in half. Divide each of those in half. I got 1, 2, 3, 4, 5, 6. Okay. Now this division actually put me right here where the blue line is. I've got them not quite on top of each other. We'll just make that a little thicker. Okay. So that's what this is. This has got to be 3/4 plus 5/8 because it's 11/8. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? That's what 11/8 means. Now 1 3/8 is a little more convenient. You know, officially, if I wasn't doing all the picture, I could just divide this interval into 8s. So I wouldn't have to divide this one into 8s because I've done the calculation. I know it's going to be 11/8, and I know that's 1 3/8. So I can just divide this interval into 8 pieces and locate the point, right? So there's a reason for the 1 3/8. Okay. Now there's an analogy to all this with polynomials. You might or might not know what polynomials are. You might have known at one point, forgotten. But I would guess that you probably aren't real conversant with polynomials at this point. That comes later. But everything that we do here has its analog with polynomials, and you want to understand it here so you can understand it there. Okay? And you want to be able to write it out formally like this. Okay? It's okay to do these in columns, but you know what I've got here. I don't want to use up a column and block what I'm trying to do over here. Okay, 2 3/8 plus 7 7/8. There are various ways to do this. One way is 2 3/8 means 2 plus 3/8 plus 7 plus 7/8. Okay. 2 3/8 means 2 plus 3/8. 7 7/8 means 7 plus 7/8. We can rearrange this addition because of the commutative and associative law. We won't get too deep into that right now. Okay? But there are laws of arithmetic, there are laws of Newton's. Okay? So we can say f2 plus 7 plus 3/8 plus 7/8. Okay. And that's going to be 9. And 3/8 and 7/8 is 10/8. Okay. Of course, 10/8 is 1 2/8, right? So we can write this as 9 plus 1 2/8, which is 10 2/8, which is 10 1/4. Now, this is the way we usually do it when we calculate, but it's one way to do it that shows you what things mean. So you want to understand it. Another way to do it is, well, 2 is the same as 8 divided by 8. No, it isn't. It's 16 divided by 8. 7 is 56 divided by 8. So of course, if you divide 8 into 16, you get 2. If you divide 8 into 56, you get 7, right? Another way of saying that is 2 times 8 is 16, so 16/8 is the same as 2. And so forth. Okay, well, all these are 8s. So we just count how many of them we have. We have 16 plus 3. I'm going to write it out in detail. 16 plus 3 plus 56 plus 7 divided by 8. Well, what's that? That's 19. 19 and 7 is 56. 56 is 19, 19, 7 is 26. 26 and 56 is 82. Okay. Which is 88 which of course is 10. It's the maximum number of 8s that you can get into 82, right? So we can get it this way, right? Or you can get it the way they showed you to do it in open math. You multiply 8 by 2, you get 16, and add 3, you get 19 eighths, right? Okay. Yeah, that's just because of this. But there you got the 19 eighths. You understand when you multiply the 8 by 2, that gives you the 16 eighths, right? And then you add the 3 eighths, giving you 19 eighths. So you can just go directly to 19 eighths plus 63 eighths. Because of course 63 is what you get when you multiply 8 by 7, you get 56. So you got 56 eighths and then 7 eighths is 63 eighths. And that equals 82 over 8. Which of course could be reduced. I didn't reduce it out here. We could say that's 41 over 4. It's another way to get there, right? And that's 10 to the 4th. Okay, so there are all these ways of doing it, and you want to understand as much of that as you can. And why it's written out the way it is, why it can be written out the way it is. Now, bottom line, you just do this, it's okay. If you do these things, it's going to help you later. Okay? Okay, well, now things aren't lined up so well, but I'll be able to do all these, I think, because this is pretty straightforward. Okay? Now, this means 1/5 divided by 7/8 times 3/4. Why do I put the parentheses around this? Because it's the first thing I've got to do. Order of operations says when you have multiplications and divisions, you do them in order. So we divide the 1/5 by the 7/9. Okay? We don't multiply and then divide by the product. When you're adding, it doesn't matter. You group things any way you want to. When you're multiplying and dividing, you've got to put things in order. Okay? Now, if you're just multiplying, again, you can do it in any order, but if you're mixing it up with divisions, you got to be careful about your order of operations. Okay, so this is then 1/5 times 9/7, because when you divide, you multiply by the reciprocal. I could explain that in basic terms, but we're not going to go that far. It's not today. And then this gets multiplied by 3/4. Now, when you multiply fractions, you multiply the numerators and you multiply the denominators. You don't have to mess with common denominators. Multiplication and division are simpler than addition and subtraction because you don't have to mess with common denominators. Okay, so 1 times 9 is 9. Yeah, we are recording. Okay. You got to keep an eye on the camera because he's going out of focus. And so actually, I'm going to write out the steps. It's 1 times 9 over 5 times 7. That's multiplied by 3/4. And we write this out to show that we understand why. Okay? And mostly to show ourselves that we understand why. So it's 9 over 35 times 3/4. And that's 9 times 3 divided by 35 times 4. And that's 27 over 140. Okay. And by prime factorizations, I know that doesn't reduce, but we'll worry about prime factorizations later. Okay. This is just 3 times 3 times 3. And 3 doesn't go into 140, so nothing's going to divide by that. I can be able to see that. Okay. Now, average of 2/3 and 3/4. How do you average two numbers? What's the average of 4 and 6? Show me if you're fingers. Yeah. Okay. Well, it's never halfway between, right? How do you calculate that? You add the 4 and the 6 and divide by 2. Now, you don't really have to do a calculation if you understand what average means. 5 and 6, you know that, or 4 and 6, you know 5 is right there, halfway between, right? But if you gotta, you know, if I ask you what's the average of 372 and 946, you can't visualize the middle of that one. You might think, it's somewhere in the 600-700 range. I don't know. Okay. So you would add the numbers and you would divide by 2. Well, that's how you average two numbers. Okay. So first thing you got to know is average is the sum divided by 2. Now that isn't always the average. Sometimes average means something a little different, but when you just have two numbers and ask for the average, that's what it means. You add them and divide by however many numbers you added. If you wanted to get the average of 7 numbers, you add them and divide by 7, right? Okay. So you want to kind of internalize that idea if you don't have it. But hopefully I just reminded you something you've always known. Okay. So that means this, right? You add them and divide by 2. Okay, well, without going through the details, 2/3 is 8/12, 1/4 is 3/12. So what we got here is that if you go through the process, you're going to get 8/12. I think, you know, watching it because sometimes I say really to the same. It's this divided by 2, right? And that adds up to 15/12. Now, divided by 2 is the same as multiplying by 1/2, isn't it? Like, if I want to average 4 and 6, 4 and 6 makes 10, right? 10 divided by 2 is 5, or 10 times 1/2 is 5. 10 multiplied by 1/2 is the same as dividing by 2. So that's 15/24. I could have reduced this to 5/4 right here. I just kept it unreduced. Did the calculation. Now I reduce.
Question.
Whoa. Please don't talk while the camera's on. If you got something to say, throw something, hit me in the back of the head and get my attention. Okay, somebody tried to call me on this problem here, right? And it was absolutely right. In the first place, the problem had 3/4 there, and I did 1/4, right? Well, I just declare now that the problem was 1/4 because it's whatever it is. We're going to add the fractions and divide by 2. But then I noticed I thought there was column B because 8 and 3 isn't 15, it's 11. Okay. So, you know, I made a couple of mistakes there, and that's why I say you got to watch me. I copied down the 1/4, which was incorrect. And I have no idea where I got that 15. No better, but I didn't do it. Okay. So there we have the correct solution. Okay. Good. Now let me think what I was going to say next. Okay. Got I think 5 questions here involving simple interest. First one is 40% of 12. Okay, what's 40% of 12? What's that equal? Well, what's percent mean? How many cents in the dollar? 100. Okay. Means means 40 per 100 or 40 over 100. Okay. Of, you're doing something of something, a percent of something, it means you're multiplying. Okay. Remember, walking into my 7th grade class, I missed the week, I was sick for a week. 7th grade math class. Mr. Fife was there. He's the coach they named the football stadium now. It's a highly competitive Division III school. Okay. And they got a couple of state champions in their league. Multiple state champions, I think. And the state champion 30 times or something like that in the last 50 years. Or in the 50 years, last 60 years back at that time. And my school's there. I should remember the state champion. Competed well. 11. But went over a couple of other games. That's pretty good competition. So this guy was a kind of a top-notch coach. Math teacher. A lot of coaches are math teachers, and maybe they aren't all that good at it. He's pretty good. Okay. And I remember him addressing me. Welcome, Mr. Smith. This is math class. I'm Mr. Fife, et cetera, et cetera. And this, Mr. Smith, and he took out this paddle from under, slammed it down on the desk and says, "This is what I do my talking with." Okay. That turns out he's a really nice guy, but he established discipline really effectively at the beginning of class. Okay. So that was pretty good. One of the first things he taught us was that of means you multiply. Okay. So, you know, the of thing just reminded me of that. But you good guy, good teacher. Okay. 40% means 40 per 100 or 40 over 100. Per means you're dividing by, right? Of means you're multiplying. Everybody clear on that? I'm sure, because otherwise you get confused. Of course, open math will explain it to you. But better off you don't have to look up their explanation, okay? Percent of 12. 40 over 100 times 12. Okay. Now you can write that out. 40 times 12 is 480. 480 divided by 100 is 4.8. Or you can change 40 over 100 to 0.4, right? And just multiply that by 12. One thing you don't do is use the percent button in your calculator. Just use the percent button in your calculator, you're going to come to college class and not know what percent means. Okay, which about half of people do. Just something to punch in your calculator and get the right answer instead of something that has meaning. So that's how you calculate a percent. Okay, continue on, see if you do things. rest of these problems. Oh crap, I didn't get that. I'm gonna say it again, but you don't have to listen. Okay, what's 40% of 12? Gonna miss the Mr. Science story. So we'll do it. I'd probably get sued by his errors if I put it up in the internet. 40% means per cent. How many cents in a dollar? 100, right? Per cent means per 100. 40 per 100. And per means divide by 40, divided by 100. 40 over 100. So 40% means 40 over 100. So 40% of 12 of means you multiply. Okay. 40% of 12 means then 40 over 100 multiplied by 12. Two ways you can do this. You can multiply this out, make that a 12 over 1. 40 times 12 is 480. 100 times 1 is 100. And that gives you 4.8. Or you can change a 40 over 100 to 0.4. Multiply that by 12, you get 4.8. Okay, so as I said, proceed on. Okay, what's 40% more than 12? Well, it means 12 plus 40% of 12, right? Now, maybe you didn't know that in advance, but if you look at this, you know, what do you mean by more than 12? It means you're adding something to 12, right? What are you adding to 12? Well, you're adding 40%. 40% of what? 40% of 12, right? Okay, that's a little complicated, but it's not hard to get used to once you see it. Okay, that's 12 plus 40% of 12, which equals 12 plus 40 over 100 times 12, which equals 12 plus 4.8, which is 16. Prefer to see a complete translation because you're reinforcing the meaning of what you're writing out. And many of you knew perfectly well, I'm going to add that 4.8 to 12. Okay. Not half the class do that. Half the class, man, a little confusion of the word. Okay. So I'm here for to confuse you a little more. Now, I want to try to write it out as thoroughly as possible so that I can see what you're thinking. And you write down the wrong thing and don't write down what you're thinking, I have no way of helping you. Okay, so bet you can get 40% less than 12 now. Okay, so I think you're going to get that. This is a curveball, like I said. You're not really, I mean, you should theoretically, when you come into this class, be equipped to solve that problem. Most people aren't, so don't feel bad if you aren't. And you should be able to do this based on the homework, because the homework is just the same thing. But if you didn't do the homework, oh, phooey. I don't know how much of that I'm going to have to say again, but I can't apologize. Usually the lighthouse. Lighthouse. Nice camera. Bad camera. Okay. Focus on the stupid lighthouse. Leave the camera. Forgive the distraction. There it is, nice and quick. For a minute there, I thought you were going to walk in front of the camera. I was going to have to tackle you, which would have killed me, and not you would have noticed. Unless I hit your knees, you know. I wouldn't do that to you. Okay. 40% less than 12. Speaking of tackles, I don't know how many football fans there are, but some really good games over the weekend, weren't they? I didn't watch them, I just tracked them a little bit. And they look like good games. I wish I would have time to watch them. Okay. Or great to play off again. 40% less than 12 means, well, minus 40% of 12, which is 12 minus 40 over 100 minus 12, which is 12 minus 4.8, 12.2. To get this one, you'll understand this one. But those are points of confusion. A lot of people miss problems about more than in less than. So make sure we got that. Okay, 20, well, we're not going to do that one right now. We're going to do this one. Because as I said, this is a curveball. All these you should be able to do based on the homework we did, except for this. This involves something you got to talk about later this week. Okay, 3% simple annual interest, $120 for 5 years. Well, 3% interest and $120. The interest is 3%, which is 3 over 100 times $120. Or, usually we will write percents as decimals. 3 divided by 100 is 0.03. 3.6, since we usually write this down in cents, it's 360, okay? 3.6 is fine. If you use 3.6, it's not a problem at all. Okay. This is for 1 year. It's annual interest, okay? Well, means the same interest every year. You've got to know that, calculate this, okay? So that means every year you pay $3.60 interest. That's unlike compound interest. And let me just do a blurb on compound interest because that's something everybody should know. I mean, to graduate high school in Virginia, you're supposed to have a course in basic economics or something like that, freshman and sophomore year. Can't believe that people come out of that course and don't know compound interest. Don't know how you can claim to have taught such a course without it, but that's what happens. So people come into college not knowing what compound interest is. Okay, most people I knew understood compound interest by the time they were 12 years old. Okay? It's not a terribly advanced concept, it's kind of obvious. And even if it isn't obvious, people could learn it fairly well at that age. So it's not a hard thing, but it's something you really need to know because there are exponential functions out there, and they're very important in pre-calculus, okay? So where you're headed, you're going to need to know. So compound interest means, okay, you add $3.60 to $120, that gives you $123.60. The next year, you compound the interest, meaning you do 3% of that, of the $120.60, which means you pay a little more interest. Just a few cents more, but you pay a little more, okay? And then now you have a little more than you would if you just paid $3.60, okay? So you're going to have a little more than $127.20, okay? And you're going to do the next year's interest based on that. And every year you're doing the interest based on what you have at the end of the year, which is your, that's your interest, right? Okay, so that's compounded. Simple contrast with compounded. So back to this problem, it's simple interest, it's not compounded. It wouldn't be hard to calculate the compound interest. You could do that for 5 years, but you have to do 5 calculations. In this case, so in 5 years, the total interest would be 5 times $3.60. $18. Okay, so you'd end up paying $138 for that $120 loan. Now that wouldn't be too bad of a deal. Okay. You don't have $120 and you really need whatever that $120 would buy. Say, okay, I believe I'll make a little money over the next few years, so I'll be able to pay that $18. Okay. So there it is. Okay, well, I promise we look at this. The way we would solve this is I'll say, well, that could be the what that your 20 is 40% more than, right? So we can say then %. It's X plus 40 over 100 times X, right? The 20 equals 1.4 times X because X plus 40 or X plus 0.4X is 1.4X. Now, again, you got to do a little work on the algebra, and I'm not going to explain all that today. You get that most likely next time. That's 1.4 times X. That's an equation now that we can solve for X. Now, you might not know how to solve that equation for X, but you might. But you will by next week, okay? It's really pretty easy. There's simple rules that we got to practice a little bit so we get good at it. Okay? Okay. Let me pause a sec. Okay, just a quick introduction to equation solving. Got X plus 5 equals 20. How do you solve that equation? Well, in the first place, you can ask yourself, well, what would I add 5 to get 20? It'd be 15, right? Well, that's not going to work if the equation's a little more complicated, okay? So we want to do it more formally. We're going to say that, okay, well, X plus 5 minus 5 then has to equal 20 minus 5. Because if this is equal to this, subtracting 5 here and subtracting 5 here, you're still going to have things that are equal. Okay? If you subtract 5 from 2 things that are equal, you're still going to get 2 things that are equal. And X plus 5 minus 5 is just X because 5 minus 5 is 0, right? And 20 minus 5 is 15, and just as you suspected, the answer is 15. Well, everybody can do that, but not everybody. Everybody can get the answer, but not everybody's going to be able to write it out for them, but you're gonna need to, okay? So that we can build on it and solve more complicated equations. Okay? Let's try this one. 2x equals 20. Okay? Well, what are you going to do to solve this? Well, you're going to say 2x divided by 2 equals 20 divided by 2. In other words, half of this side equals half of this side, right? If these two are equal, then half of this is going to equal half of this. And when you divide 2x by 2, I'm going to get a little more formal in this. You can write that as 2 over 2 times x over 1. And of course, 20 divided by 2 is 10, right? Now, most people are going to cross out the 2, cross out the 2, but people don't understand the rules of cancellation. People come into calculus classes don't always understand the rules of cancellation, much less pre-calculus classes. So I don't allow it. Not at this level. It's clear that if I multiply the numerators and multiply the denominators, I'm going to get this, right? Okay? So this is clearly true. But what's 2 divided by 2? That's 1. Times x divided by 1 equals 10. But x divided by 1 is just x. And 1 times that is just x, right? So x is 10. Okay. Real quickly. This thing here. You divide both sides by 1.4. So x is 20 over 1.4. That's approximately 0.71. 0.71 times 20. Approximately 14.2. Okay. Now, use a little way the equal signs for approximately. Okay. I'm a sign, we're going to recommend that you check it. Okay. Maybe that should have been 14.3 because I come up with just a little less than 20. Like 19.8 or 19.9.